So today we are starting our next class, Lagrange's interpolation formula. So first we discuss the method Lagrange's interpolation formula. This method is used for in general unequal interval. Suppose y equals to fx be a function of an independent variable x and a dependent variable y. Then the values of x and y are tabulated in this form. X is x0, x1, x2, x3, xn, y equals to y0, y1 up to yn. And then we are assuming our interpolating formula or polynomial, that is fx equals to a0, x minus x1, x minus x2, x minus x3, x minus xn, plus a1, x minus x0, x minus x2, x minus x3, x minus xn. A2 x minus x0, x minus x1, x minus x3, x minus xn, up to an x minus x0, x minus x1, x minus x2, x minus xn minus 1, where a0, a1, a2 up to an are all constants that we have to determine. Now we are putting x equals to x0, x equals to x0 means f of x0, that is a0, x minus x0 up to this. So what is a0? A0 is f of x0 divided by x0 minus x1, x0 minus x2, x0 minus x3, x0 minus xn. Next we are putting x equals to x1. Then f of x1 equals to a1 into this. So a1 equals to f of x1 divided by x1 minus x0, x1 minus x2, x1 minus x3 up to x1 minus xn. Similarly, an equals to f of xn divided by this. Now we are after finding these constants, we are putting these values in our assuming polynomial. Then what we are getting after putting these values? This is our polynomial. Fx is x minus x1, x minus x2, x minus x3, x minus xn divided by x0 minus x1, x0 minus x2, x0 minus x3, x0 minus xn, f of x0, x minus x0, x minus x2, x minus x3 up to x minus xn, x1 minus x0, x1 minus x2, x1 minus x3, x1 minus xn into f of x1 up to x minus x0, x minus x1, x minus x2, x minus xn minus 1, xn minus x0, xn minus x1, xn minus x2, xn minus xn minus 1, f of xn, where x is the point where interpolation is to be done. So the formula may be written in compact form as y equals to fx, I equals to 0 to n, summation over j equals to 1 to n, x minus xj, j equals to 1 to n, xj minus xi minus xj, f of xi, where I not equals to j. This is our Lagrange's interpolation formula. Error in Lagrange's interpolation formula. Lagrange's interpolation gives very good result for polynomial interpolation. The error in the formula is Rn plus 1x equals to Pn plus 1 by n plus 1 factorial f to the power n plus 1 epsilon, where x0 less than epsilon less than xn, where Pn plus 1 equals to x minus x0, x minus x1, x minus x2 up to x minus xn, and fx is Lagrange's polynomial. For computation, Lx equals to omega x, summation over r equals to 0 to n, f of xr divided by x minus xr, w dash xr, where that wx is x minus x0, x minus x1, x minus x2 up to x minus xn. Wx summation over yr by dr, yr is f of xr, dr is x minus xr, xr minus x0, xr minus x1, xr minus xr minus 1, xr minus xr plus 1, xr minus xn. Now advantages and disadvantages of Lagrange's formula. Advantages: Lagrange's method can be used in regular and irregular interval of x. Next is the method can be used for any value of x at any position, such as beginning, middle, end, or outside of the table. Number 3, the method has been derived by nth degree polynomial with n plus 1 data, and hence is supposed to give best results for polynomial fitting. Next, inverse interpolation is obtained by interchanging x to y and vice versa. No need of making reference table. Computer implementation is easier. So these are the advantages and disadvantage. The method is very lengthy and not suitable for hand calculation. Next, for increase of the degree of interpolating polynomial by adding new interpolating points, the whole calculation would be made fresh. Next, we have one problem. So we have to find f of 1.5 from the following data. So data set is given, values of x, values of y both are given. So this is the Lagrange's interpolation formula, already we discussed. Now we are finding these values x minus x0, that is x0 minus x1. So actually this is x0, this is x1, this is x2, this is x3, this is y0, this is y1, this is y2, this is y3. So x minus x0, this is x, x1 minus x0 1, x2 minus x0 2, x3 minus x0. Similarly, x0 x1, x minus x1, x2 x1, x3 x1. We can compute all these values. x0 minus x2, x1 minus x2, x minus x2, x2 minus x3, x0 minus x3, x1 minus x3, x2 minus x3, x minus x3. First we compute all these values. Here that means there is what? X minus x0, x minus x1 into this, into this. So this is minus 6x, y are 1. Similarly, if we multiply all these values, this is 2 into x minus 1, that is, and y are is 2. Multiply these factors, we are getting minus 2 into x minus 2, that is 11. Multiplying these factors, we are getting 6 into x minus 3, that equals to 34. Omega x equals to x, x minus 1, x minus 2, x minus 3. Next, we are calculating. Then from this interpolating formula, after calculating, we are getting our Lagrange's interpolation formula Lx as x into x minus 1, x minus 2, x minus 3, minus 1 by 6x plus 2 by 2 into x minus 1 plus 11 by minus 2 into this. Then after calculating, we are getting these values. Now we have to find f of 1.5 in place of x. If we are putting 1.5, we are getting this answer. This is a one procedure. Now here we are using another one procedure. Say we have to compute Lagrange's polynomial. Then we have to find f of 5 from the following data set. This data set is given. This is x0, this is x1, this is x2, this is x3, this is y0, y1, y2, y3. Then from Lagrange's interpolation formula, fx is this. X minus, this is actually fx is what? X minus x1. From here we are computing this. X minus x1, x minus x2, x minus x2, x minus x3 divided by x0 minus x1, x0 minus x2, x0 minus x3 into y0 plus x minus x0, x minus x2 into x minus x3 divided by x1 minus x0, x1 minus x2 into x1 minus x3 into y1 plus x minus x0, x minus x1, x minus x3 divided by x3 minus x0, x3 minus x1, x3 minus x2, x2 minus x0 into y2 plus x minus x0, x minus x1, x minus x2 divided by x3 minus x0, x3 minus x1 and x3 minus x2 into y3. Then we know all these values, we are putting all these values here, and after calculating we are getting the value of f of 5 as 11.54. Hence, there is another one problem. Find polynomial with the help of Lagrange's interpolation formula from the following data. Hence, we have to find f of 5 and f of 12. This is the data set. This is x0, x1, x2 and x3. This is y0, y1, y2 and y3. Then from Lagrange's interpolation formula, we have to find out yx. This is the formula. After simplification, we are getting this is as x cube plus x plus 1. Therefore, the required formula, this is our required polynomial. Then we are putting in the place of x5, we are getting this answer, and in place of x we are putting 12, we are getting this answer. So do these problems for your own solving up to this. So thank you.